The legend lives on from Muckluck on down of a hovercraft called the Jeff-A. Northward it came with its turbines aflame, shining in the sun's bright midnight rays. So Ohio said, drill out in Harrison Bay, there's oil to be found out in Muckluck. So the Jeff-A came north and RMI brought forth a crew that they hoped would bring good luck.
The only gentle thing about this land at the top of the world is the slope of the land itself. Gradually descending from the Brooks Range, which marks the North Slope's southern boundary, to the edge of the Beaufort Sea. It was in the process of drilling beyond Prudhoe, in the nearshore ice of Harrison Bay, that Ohio encountered the seasonal frustrations of this coastline, which threatened to halt the surface movement of men and equipment.
When we first moved from the onshore area in the Arctic to the marine environment or the ice environment in the Beaufort Sea, it quickly became apparent to us that ease of transportation in that new medium was absolutely essential. Not only did it help in logistics, but also it controlled costs of operating the Beaufort Sea. We also found, after drilling a few wells, that it was desirable to be able to operate during break-up and freeze-up when conventional vehicles simply can't move on the sea ice. And so we gravitated towards the idea of using a hovercraft to conquer these periods of time which apparently were very difficult with any other conventional mode of transportation. First, we used a hover platform which could carry great weights, but it had no self-propulsion. We pulled it and we pushed it, and it worked quite well, but it showed the desirability of having a self-propelled vehicle. We set about designing such a vehicle, especially for the Arctic.
By the end of April 1983, the planning and design stage for the self-propelled ACV 300 was complete, but Ohio weren't absolutely certain that this design would meet the technical and environmental requirements for operation in the Arctic. RMI from San Diego came on board at this time, and it was at this stage that the modifications to the craft took place.
November 1983, the Jeff-A was secured in its own hangar at Ohio's East Dock Camp on the Alaska Beaufort coast. As leased from the Navy by RMI, the Jeff-A was designed as a prototype assault landing craft and was built to operate in far more temperate climes. Modifications were necessary. Safety and certification requirements for the Coast Guard. The existing skirt system, which was neoprene, was replaced with natural rubber to better withstand the cold. And every effort was made to protect all exposed working parts. Keep things warm became the overriding design message. Hydraulic and fuel systems, gearbox lubrication. Everything from seals to fluids to electronic devices were insulated or heated directly. Exposed to the harsh and unforgiving environment of the Arctic, the Jeff-A, freshly transported from sunny Florida, would now be called upon to operate in temperatures as low as minus 50 degrees below zero and to carry payloads up to 100 tons. Thus began the trial of the Jeff-A by offering an opportunity to collect data over a much wider range than previously possible.
The Jeff-A test program was divided into 3 phases spanning the range of ice conditions from relatively smooth young ice in the fall through ridges and rubble fields in midwinter, and eventually to the most challenging condition of ice breakup in July. The primary objective of the Jeff-A test program was to collect basic engineering data which would allow the prediction of hovercraft drag over a variety of ice surfaces. This information is critical in order to select the appropriate installed power in any large hovercraft of the future.
Using load cells capable of resolving load differences of less than 20 pounds, bollard testing was conducted at the beginning of each test period to measure propulsor thrust at different engine power settings and cushion thrust over a range of trim angles. The tests took place on a surface area plowed level to reduce the possibility of measurements being influenced by skirt stiction. These measurements proved to be essential in interpreting all other trial records. In the cushion thrust and propulsor thrust became significant corrections in the derivation of actual skirt ice resistance. Over-ice drag tests formed the core of the program. The smooth over-ice drag tests were accomplished by connecting the bollard test bridle and load cell system to a Rollagon, an ATV rubber-tired vehicle. The tests were performed under varying conditions, towing the Jeff A from both bow and stern, using 2 Rollagons, towing with engine shut down, and towing against cushion thrusts over smooth ice and rough. And as always, against the forces of wind and cold and darkness. In midwinter, the sun never rises above the horizon of the North Slope, and the tests were conducted in a climate which dramatically focuses on deficiencies. Yet regular checklists reflect steady progress. The modification of the Jeff A, procurement of spares and repair parts, the training of personnel, developing a viable operation base, building a team, and adding to the learning curve of ACV operations in the Arctic. Today, it's smooth ice thereafter, this time for maneuvering trials, designed to measure the craft's control over ice, using the thrust from its 4 gas turbine engines, each 3,750 horsepower, to see how this 92-foot-long vehicle navigates through an obstacle course, to turn and to stop, and if not to curtsy, at least to pirouette. A self-propelled ACV is influenced by the strength of the wind, and maximum operating wind speed was about 40 knots. To assist the pilot, who frequently found it necessary to operate the craft in complete darkness and occasionally under whiteout conditions, a Solitas microwave navigation system was installed.
Realising up there that there's nothing outside the craft to judge your speed by, it's just white. There's the white of the snow, the greyness of the clouds, and the speed is just not evident to the pilot.
Drilling here to place the microphone, sound experiments were carried out mainly to convince the native population that the Jeff A was not as threatening as it might first appear to be.
During the sound measurement testing, we felt it important that we should use equipment that the natives could relate to, such as a skidoo, Rollagon, and then compare those noise sounds both above water and below water with that of the air cushion vehicle.
The noise level from the Jeff A was determined to be comparable in volume to the noise level of the other machines tested. The noise made by footsteps on the ice resounding louder, as picked up by the microphones. 10 miles north of Ohio's East Dock base, a continuous pressure ridge serves as a setting for the ridge crossing tests. A clear area of smooth ice was available on both sides of the ridge for approach and departure, and marked accordingly. A combination of towed and self-propelled tests were used, with the towing vehicle again being the Rollagon. The tests were used to indicate how much skirt resistance would be experienced over a 4-foot ridge.
Hey, Langdon, we're going to run up the aft prop zoom. It'll be another few minutes here. Okay, thanks.
Tests were terminated when the Jeff-A began to overrun the cable after accelerating downslope. During the self-propelled tests, the Jeff-A made a series of runs to determine the slowest approach speed necessary to negotiate the ridge. An important consideration in selecting the optimum power for future Arctic ACVs. But it was also one that would have more immediate application, for the question now had become more than academic. Circumstances demanded an immediate answer. Could the Jeff-A, designed as a high-tech prototype assault landing craft, become a successful role model in solving the oil industry's offshore transportation problems? The clincher was a man-made gravel island 41 miles out in Harrison Bay named Muckluck.
The drilling had been completed on Muckluck Island. It would have been too costly to wait until August for tugs and barges. The ice conditions were unstable, and it was very doubtful that an ice road could be constructed with the required integrity and safety. It was decided to utilize the ACT-100 and the Jeff-A for the demobilization of Muckluck Island. These large and powerful craft were the only vehicles available which could do the job.
In rough ice tests Jeff-A had experienced earlier, the craft had always operated within the safe limits imposed by its cushion depth of 4 feet. However, surface elevation profiles had indicated ridge height well in excess of that figure in the vicinity of Muckluck, which it had to overcome, and did.
The Jeff-A hovercraft is capable of high speeds over smooth ice. However, a safe cross-country speed would be below 40 knots. The Jeff-A can easily cross ice ridges 3 or 4 feet high. However, this 7-foot high ridge was easily negotiated with only minor skirt damage.
Yet to be resolved was the extent of Jeff-A's cargo carrying ability. Here again, Muckluck would supply the answer. Hovering only a few feet above a shifting and unstable terrain, the Jeff-A would be called upon to follow a precisely marked course between Muckluck Island and Milne Point.
The route that the craft would be taking was surveyed for any abnormal ridges, and then the route plotted out on a chart. Where there were alterations of courses, or waypoints as they're called, a radar marker was placed at these strategic points. Then the navigator in the craft would pick up the marker on his radar screen and advise the pilot of when to adjust course to keep to the track.
As with an airplane or a ship at sea, whose paths are plotted to accommodate the variables of wind or ocean currents, so must the Jeff-A, being neither plane nor boat, but incorporating elements of each, respond in like manner to ridge height and ice rubble. Ironically, the Salidas antenna, whose instrumentation is heavily insulated against the ravages of weather, escaped the fate of some of the radar markers, which were attacked by polar bears and left in a rather mutilated condition. The actual rig and camp demobilization of Muckluck did not begin until everything else had been removed from the island. In order to disassemble the drill rig, a huge crane was transported from the staging area here out to the island. The boom and the counterweights were carried by Rollagon, and the tracked body was carried by the Jeff-A. The crane, which weighed in excess of 102 tons, had been hauled to the staging area by truck from Electoc Point over grounded ice. From this point on, it would proceed by ice trail to Muckluck Island. Because of the unstable nature of the ice, rollagons, hovercraft, and sleds would be used to evacuate the rig. 4 trails had been built to minimize the impact. While the results from the Muckluck well were disappointing, the overall drilling program had been a success. The largest man-made gravel island built to date in the United States was constructed in record time under adverse weather conditions. A drilling rig had been barged to the island and set up, when in past years, ice would have prevented such an operation. The evacuation now would be largely handled by hovercraft. The Jeff A, which on February 13th, 1984, accomplished a single lift of 102 tons, and the ACT-100 hover barge, which also did Trojan duty, hauling a total of 15 loads between Muckluck and the staging area, towed by 2 rollagons. The ice trails from the staging area to Muckluck were built on floating ice in water depths ranging from 10 to 48 feet.
At about 12 knots, this critical speed would cause the ice sheet to fail. The ice sheet would also fail by just merely overloading the ice.
A rapid drop in temperature could cause the ice to crack from thermal stress. Time and cold weather, along with spot flooding, are the elements required to repair the trails. Once a pattern is set for cargo weight and dimension, and the approximate center of gravity located, loading with the crane over the side of the ACV, or with the loader using the ramps, can become routine.
Muckluck Island operation was used as the operational vehicle for establishing cargo hauling characteristics of an air cushion vehicle in the Arctic. How well would an ACV fit into the logistics network of the North Slope? This is a question that was attacked and to quite a large extent solved in the early cargo runs of the Jeff A from Milne Point to Muckluck Island.
In the 2 runs to Muckluck Island on February 21st, 1984, the Jeff A carried a total of 294,000 pounds of cargo. Shortest one-way transit time to Muckluck, 41 miles in 1 hour, 17 minutes. Highest sustained operating speed, 50 knots. Because of the extreme cold, it was necessary to keep the island's power plant engine running, even as it was loaded aboard the ACT-100 hover barge. Aboard the hover barge, the operator increases the cushion thrust to compensate for the tremendous weight now being carried. The entire demobilization process, from the time the ice road and trails were started to when the last piece of equipment left the staging area, took 28 days. Without the hover barge and the Jeff A, the move would have required more time and more money to complete, if indeed it could have been completed at all by any other means.
The final analysis of Jeff A test results is still underway, but some major findings have surfaced so far. We achieved all of the original test objectives, due in large part to the tremendous cooperation of everybody involved. Jeff A performed beyond expectations and enabled an overwhelming amount of data to be collected in a very short period of time. Significant differences were found in skirt resistance. The very worst condition was starting from rest in rough ice, which took over 4 times as much thrust as moving slowly over smooth ice. This is considered the critical design case for any future Arctic hovercraft. With the results of the Jeff A program, designers in the future will be in a much better position to develop efficient, cost-effective Arctic hovercraft to solve the oil industry's offshore transportation problems.
Sohio's research program indicates that future Arctic ACVs will quite possibly be diesel-powered and will not be near as complex as the Jeff A, nor may they even resemble their hard-working prototype. But they will possess certain characteristics in common. They will easily traverse water, tundra, sand, and ice. Hoisting a 150-ton load, they will transit over shoal areas and river deltas where tugs and barges cannot. Here at Alaska Island, the Jeff A minimizes the need for docking facilities by its ability to climb beaches.
From RMI's perspective, the Jeff A Arctic demonstration program, which combined the utilization of an air cushion vehicle and the dedication of a crew of people to make it operate effectively, was a success. Sohio gathered a substantial amount of data, both operational characteristics and logistics information, such that very effective transportation studies could be carried on.
Due largely to the Sohio-sponsored Jeff A Arctic program, the design database for future Arctic air cushion vehicles has been well established. And those who drill for oil on this far north coast need no longer be bound by the restrictive parameters of offshore transportation in the Arctic.
To a camp they do say on the shore of the bay came the Jeff A one cool summer's evening. The Arctic is harsh, ain't no Florida marsh, and the crew set to work, hammers ringing. So out to the bay on these fine sunny days went the Jeff A to make her own history. Will the Jeff A live on in the bright Arctic sun, hauling oil rigs ever farther and faster?